Welcome back. So let's now start understanding what we are going to do in this project, right? So basically we want to recognize the gender, okay, using SVM. So it's a gender recognition task by voice and speech analysis. So if we go to this link, you will see that we go to Kaggle, okay, and as you can see, this is a dataset, gender recognition by voice, identify a voice as male or female, and it was updated 4 years ago, okay, and we have more than 500 people try to use this dataset for visualization, for machine learning tasks, for deep learning tasks, whatever, right? You can check this tab and you will see all the notebooks and you can filter the notebooks and so on, right? So let's look at the data. As you can see here, it's saying that this database was created to identify a voice as male or female based upon acoustic properties of the voice and speech. The dataset consists of more than 3,000 recorded voice samples. So we have more than 3,000 recorded voice samples collected from male and female speakers, okay? And the voice samples are pre-processed by acoustic analysis in R using C-Wave and TuneR packages with an analyzed frequency range of 0 Hz to 280 Hz. And this is the human vocal range. So anything above this range, you cannot really hear it, okay? And let's look at the dataset. So let's go back to the notebook, right? You can see everything here and you can see the accuracy of the baseline model, the logistic regression, the chord, the random forest, the SVM, and the XG posts and so on. So we have some questions here and so on, right? And this is the dataset. Now let's go back to the notebook. The dataset features, we have the following acoustic properties of each voice, and they are measured and included within the CSV. So we downloaded the CSV and we have it right here. It's currently being uploaded, right? And the features are basically the mean frequency in kilohertz, the standard deviation of the frequency, the median frequency, the first quantile, the third quantile, all of this in kilohertz, the interquantile range, the skewness of the data, and the curtices. And we have also something called the spectral entropy, the spectral flatness, the mode frequency, the frequency centroid. All of these are actually features that we can get from the voice, right? We can get from the speech. The peak frequency, the same, average of the fundamental frequency measured across acoustic signal, minimum fundamental frequency, maximum fundamental frequency, average of dominant frequency, minimum maximum of dominant frequency. So all of these are features we can get from the signal we have. Which signal? The voice signal or the speech signal, okay? All of these are features we got using R, as we said. So we have all the data pre-processed for us. So we have these features. We don't really have the audio files themselves, okay? We have some values and we want to classify based on these features if this specific person is a male or a female, right? So we are going to load the dataset and we will do this starting from the next lesson. So in the next lesson, we will load the dataset, we will find the correlations, we will see if we have any null values, we will do the data separation, encoding, and standardization, and then we will run the SVM with default hyperparameter, with the default hyperparameter we have in sklearn, and then we will try to check different kernels, okay, and see which one is giving the best result, and then we will investigate the hyperparameters more and more. So we will perform cross-validation with linear kernel, with RBF kernel, and we'll check the C parameter or the C hyperparameter, the gamma hyperparameter, and so on. So let's start from the next lesson, seeing how we can work on this project if you're interested. Okay, so let's go.